Welcome in. In this video, our learning objective is to predict the ionic charge for our main group elements whenever they exist as ions. We know from our previous videos that our atoms exist as a combination of protons, neutrons, and electrons. Last time we talked about what happens when our protons change. Now we're going to focus on our electrons. What happens if we change the number of electrons in our atom? The answer is that we form what are called ions. Whenever you add or remove electrons from your atom, you do not change the identity of that element. You do not change the mass of that element in any meaningful way, but you do change the charge of that element. Ions are going to be species that have some charge imbalance. These ions could have too few electrons, and end up as positive, or they could have too many electrons and end up as negative. We call our positive ions cations. We call our negative ions anions. If you want a silly way to remember that, cations are positive, just like our cats have paws. Those cations are our positive ones. We said before we can calculate that total charge. All you need to do is add up the number of positive charges and the number of negative charges. If your total charge is 0, we call that neutral. All right, so if we change the number of electrons, we change the charge. We form either cations or anions. But what does that change? What does that matter? The answer is our ions behave extremely differently than neutral elements. If you have neutral sodium, this is one of our group 1 metals, one of those alkali metals, which is extremely reactive. However, if you form a sodium cation, this is what we have in our table salt. This is what makes our food taste more delicious. Another example, neutral lithium. Again, this is one of our alkali metals, extremely reactive with water and fatally toxic. But if you form a lithium cation, lithium with a positive charge, this is one of the best treatments for bipolar disorder. Changing the charge on our elements wildly changes those properties. As a corollary, the charge that we have on our ions dictates what will react with each other. As we know, opposites attract, and so if you're trying to form a compound, you'll need to have one positive ion combining with one negative ion. Likewise, the value of those charges affects the ratio that you get to form your compounds with, because we want to have our compounds as neutral. Much more on this in our coming chapters. We have some examples that we can run through. If you want to calculate the charge that is present, we need to know how many protons and how many electrons are present on that atom. Recall that the number of protons is dictated by what element that we have. So if you look up nickel on the periodic table, nickel is always going to have exactly 28 protons because it's nickel. Now we can calculate the charge. We can take the total number of positive charges, which is 28, and we can subtract the total number of negative charges, which is our 26 from our electrons. Our charge here is going to be 2, and in fact is a positive 2. For ions, we like to write the number first, followed by a positive or negative sign. In this case, we can say our charge is 2 plus, because we have, oh look, we have 2 extra protons compared to electrons. We have 2 extra positive charges compared to our negative charges. We can likewise find bromine on the periodic table. This is element number 35. This is going to have 35 protons. Here we know we have 36 electrons, so our total charge, 35 protons minus our 36 electrons, we end up with a value of -1. Or we can say our charge is 1 minus. Notice here, we can write our chemical symbol as well. Bromine is the letter Br. If you're including the charge on your chemical symbol, the charge is written to the top right. And if it's a 1 or -1, we can just write the positive or negative and say we have, okay, Br minus. That charge is always written to the top right. Likewise, for our first problem with nickel, we could write our chemical symbol as Ni for nickel with a charge of 2 plus. Write that as a superscript to the top right. Nickel 2 plus. Number 3, I'll leave as practice, but we can do this second problem at the bottom. Determine the protons and electrons in this S2 minus ion. The first part, actually good news. The number of protons, we can look at the periodic table. Sulfur is number 16. It has to have exactly 16 protons. To find the number of electrons, we still have our formula, but now we just know different information. In this case, we know our charge is -2. And if we have 16 protons, we need to have some number of electrons to get to that total charge. Solving this little algebra problem, we get to have 18 electrons. Fantastic. If we know how many protons and electrons we have, we can calculate that total charge. We can go one step further, actually. For our main group elements, we can predict what ion is going to form. Our main group elements are predictable in what kind of charges that they will adopt. The theory for this is a little bit too complex for us right now, but we'll get back into this in a later chapter. For right now, we'll just introduce a shortcut or a trick to decide how many electrons an element will gain or lose in order to form a stable ion. The way I like to do this is to play a little game of chutes and ladders on the periodic table. As it turns out, our main group elements will add or remove electrons until they have the same number of electrons as the nearest noble gas. This is almost always going to be 8 valence electrons, which we'll talk about more in our future videos. You can go forward on the periodic table. This is going to be adding electrons and forming anions. Alternatively, you could go backwards on the periodic table. This is going to be removing electrons and forming cations. The number of boxes that you need to move on the periodic table is how many electrons are added or removed. Let's do oxygen as an example. Oxygen is here, number 8 on the periodic table. We want to end up with our noble gas box. So I see 2 choices. You can either go 1, 2 boxes over, 2 boxes to the right, or you can go 1, 2, 3, 4, 5, 6 boxes backwards. When you have two choices like this, we're going to pick the fastest route that gets us to the noble gas column. So instead of going backward 6, we can just go forward 2 boxes. Forward is adding electrons. Oxygen will form a ion that has a charge of -2. A second example, we can look at aluminum. Aluminum is element number 13 down here. We have two choices. We can either go 1, 2, 3, 4, 5 boxes to the right, from 13 up to 18. Or we can try to go backwards and go 12, 11, down to 10. That is going to be 3 going backwards. Which of these seems like it's easier? Well, 3 is easier than 5. So here we get to go backwards 3 spots. We get to form aluminum 3+. When we start to apply this rule to the whole main group area of the periodic table, we start to see some patterns. Everything in column 1, our alkali metals, likes to form a +1 charge because you can just hop backwards 1 square and get over to that noble gas column. Everything in group 2 likes to form a +2 charge because, again, you can hop backwards just 2 squares and get to this noble gas column. On the right side of the periodic table, group 17 likes to form a -1 charge because you can just hop 1 spot to the right, 1 spot forward. Group 16 likes to form a -2 charge. Group 15 is going to form a -3 charge. And for group 14, actually we get kind of a weird case here. This is carbon. Carbon can go 4 boxes forward, or it can go 4 boxes backwards. Maybe this is more of a case-by-case thing. The real answer is that carbon doesn't really like to form ions, and instead will do a different type of bonding. But at least we have a pattern for groups 1 and 2, and then groups 15, 16, 17 on the right. All right, we've done some examples. Now we have a practice problem for you all. Grab some paper and decide what is the charge for nitrogen, what is the charge for a calcium. See if you can get it. Well, there we go. We've accomplished our goal. Now we can predict the charge for our main group elements when they form ions. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.